Hi, all. This is Dr. Golla Naresh KUmar from the Department of Electrical and Electronics Engineering, working as a STEM professor and BV Raj Institute of Technology. Today, we are going to discuss on the subject of principles of electrical and electronics engineering. I am going to give a brief overview of the syllabus, which is going to be held for the first year students of all the branches. Yeah, coming to the overview of the subject, first, what is the main objective of studying this subject? Here we can see that we have the subject is common for the CSC and the allied branches and the core branches of ECE, EEE and BME. So what is the main objective of studying this subject for all the branches is, the main objective is that every student should be familiarized with the principles of electrical circuits, the network theorems and electrical machines. Why? Because in the day-to-day life, they are going to go across the various circuit designs in their own houses, in all the applications what they are going to use, as well as the network theorems. There we are going to analyze the circuit and we are going to find the response in the circuit, but various techniques. And the various types of electrical machines, we can see the generator, motor, the alternator, where we are going to see in our day-to-day life. So it is going to be very much interesting for students and should have a basic knowledge irrespective of the stream. So that is the main object of implementing this subject for the entire branches. And you are also going to go through about the analysis and design of the diodes and the junction transistors. The first part is going to be familiar with the electrical circuits and electrical part. The second part is going to be familiar with the electronics part. So we can see a chip designing, a design of the circuit. We can see the diode, transistor, so various types of components what we are going to use in the designing of the circuit. So this subject is going to play a key role for every student. Yeah. Now we'll go for the overview of the subject. What are the contents we are going to discuss in the subject? Here we can see, coming to the first chapter, we are going to study the basics of introduction to electrical circuits. So here what we are going to study is, first we are going to have an idea on the basics of voltage, current and power. And we have certain elements like resistor, inductor and capacitor. And we have the different types of sources like voltage source and current source. And in order to transform the source from one source to the other, we have the concept of source transformation. How to transfer the source from one form to the other, either voltage source to current source and vice versa, how the process is going to be. And we have the voltage and current relationship for various types of elements. There is a passive elements like resistor, inductor and capacitor. Now what is the relation we are going to get for voltage and current for these elements? And we have the basic laws, which is known as Kirchhoff laws. So Kirchhoff is a scientist who has concluded the laws. We have Kirchhoff's voltage law and Kirchhoff's current law. What is the statement of the laws and what is the application of that laws? That's what we are going to study here. In the intermediate +2, they are going to study on the basics of Kirchhoff laws, but here we are going to study the application of the Kirchhoff laws, how we are going to apply that on the circuits. And we have certain network reduction techniques. If there is a complex circuit, the design, in order to reduce the circuit, this network reduction technique is going to play a key role. So what are the contents we are going to study in this part is how to reduce the series network, parallel network and the combination of series and parallel networks, how to reduce a circuit and find the response. And there is one more concept of star to delta and delta to star. So what is the main objective of this concept is, there are some circuits where we cannot solve by using series and parallel combination. In order to reduce the circuit, we are going to use this concept of star to delta and delta to star transformation. Next, we are going to have the application of the Kirchhoff laws, that is Kirchhoff's current law, which is the node analysis, and the application of Kirchhoff's voltage law, which is the mesh analysis. So in the node analysis, we are going to find the node voltages, and with the help of that node voltages, we are going to find the response in the circuit. Whereas in the case of mesh analysis, we are going to find the loop currents. With the help of the loop currents, we are going to find the response in the circuit. And analysis to that, we have super node and super mesh analysis. And we have the problems what we are going to solve with various types of techniques, network reduction techniques and the mesh analysis and node analysis. This is regarding the first chapter. Come to second chapter. The second chapter is completely relying on the AC circuits. So first we are going to study on what is the difference between the AC circuit and DC circuit, how it is going to differ from that. And we are going to have the basic definitions of RMS voltage, average voltage, there is the average value, you can say average voltage, average current, whatever may be the case for the given waveform. And we are going to have some factor which is known as form factor and peak factor. We have a peak factor also for here. And how we are going to apply this concept for various types of input signals like sinusoidal, trapezoidal, square, triangle. For different types of input signals, how we are going to find these values. Next, we can see the steady state analysis of resistor, inductor and capacitor in various analogies like series circuit, parallel circuit and series and parallel combinations. How to reduce the circuit? In the first chapter, we have studied around the resistor, inductor and capacitor for DC circuits and how it is going to differ for AC circuits. That we are going to study in this chapter. And here, that is excited by DC circuit, DC voltage in the case of first chapter. Here we are going to excite by using the sinusoidal excitation. Nothing but AC voltage, what we are going to give here. Here we are going to get an additional factors like reactance, impedance, susceptance, what are these parameters, how it is going to differ from DC circuits, that we are going to study here. And we have the concept of phase and phase difference. What is this phase difference? Why don't we get in the DC circuits? That we are going to study here. And we have the concept of power factor, which is going to play a key role in our day-to-day life for billing the for electrical bill what we are going to get. And we have different types of powers, real power, reactive power, and we have apparent power. So different types of powers, and we have the concept of power triangle. And again, we have the basic problems on this concept of different types of powers, as well as the concept of impedance, reactance and susceptance, that we are going to study in the second chapter. Come to third chapter. In the third chapter, first we are going to start with the network theorems. So whatever may be the concept we are going to study in the first and second chapters, like mesh analysis, node analysis, and whatever the analogy we are going to study in the AC circuits, that we are going to implement in the case of the third chapter, which is the network theorems. So here we are going to study the Thevenin's theorem, and we are going to study the Norton's theorem and the superposition theorem. So here we are going to analyze, we are going to apply the concept of mesh and node analysis in the network theorems. Next, here we are going to find the response for each theorem. We have certain procedure, we have statement and certain procedure to find the response. So based on that procedure, we are going to find the response for the each theorems. It is very much interesting to study the theorems and find the response. Next, we have some certain problems to solve on that theorems. But here we are going to study only on the DC excitation, not the AC excitation. Why? Because this is subject is common for all the branches, so on that basis they have solved only for DC excitations. Next, here will come the electrical part, most interesting, which is the DC machines. So the second part we are going to get completely on the machines part. So first we are going to start with the DC machines. So in the DC machines, we are going to study the DC generator and DC motor. So here we have to keep in mind that whatever may be the machine, first we are going to study its construction, principle of operation and its application. These are the basic terminology what we are going to analyze, what we are going to study for the machines. So starting with DC machines, first the construction, principle of operation of DC generator and DC motor, and what are its types, And we have the EMF equation for the DC machine and the applications that we are going to study the DC machines. Next, we have small numerical problems on the EMF equation. And coming to the AC machines part, here we have three types of machines what we are going to study. First, starting with the single phase transformer. And the second is the three-phase induction motor. And the last one is the alternator. So whatever may be the machine, what we have said, we are going to study the construction and its principle of operation and its applications. So here, we are going to study the construction and its operation, so which we are going to get a basic idea on how the function of generator is going to work, motor is going to work. We can see these machines in our day-to-day life, starting from our houses, in the water pumping in the agricultural sector. In the case of generating stations, we have alternators. So how they are going to function, so that everyone should have an idea. That is the main objective of studying the concept of these machines in the subject of principle of electrical and electronics engineering. Okay, here we comes the first three chapters. We are going to study on electrical part. Next, we are going to get on the electronics part. In the electronics part, we are going to start with the basics of PN junction diode. I hope already everyone is going to have some idea on what is a diode in your plus 2 classes. Here we are going to just review with that of PN junction diode and its characteristics. Next, here we go for the applications of it. We have how the diode is going to act as a rectifier. We have different types of rectifiers, half-wave rectifier and full-wave rectifier. In the full-wave, we have again two types, center-tapped and bridge rectifier. So whatever may be the type of rectifier, first we are going to study its construction and its operation, how it is going to function, and what are its characteristics. That is very much important. What is the function of a rectifier? What are different types of rectifiers and how it is going to function? And how the characteristics we are going to analyze for the different types of rectifiers. And that we are going to study with and without filters. What is a filter? What is the use of filter in this rectifier circuits? What happens if I does not use a filter? All these contents we are going to discuss in this part with the help of capacitor filter or inductor filter. We are going to use for different types of rectifiers, how it is going to differ. And we have some special purpose diodes known as some Zener diode, SCR, that is silicon controlled rectifier, tunnel diode, and a varactor diode. So this type of various types of diodes, how we are going to use, how it is going to be differ from normal PN junction diode. Starting with that point, how it is construction, how its operation, what are its applications. All this point we are going to discuss in this special purpose diodes. So the fourth chapter is going to completely cover on the types of rectifiers and all the special purpose diodes. Here comes the last chapter, which is the transistors, bipolar junction transistors. So here we are going to start with what is a transistor, how a transistor is said to be formed, what is its construction, what is its operation. That we are going to start. First, we are going to study the construction of BJT and what is its symbol and what are its how it is operation, how the movement of charge carriers is going to take place in the transistor of PNP and NPN. We have two types of transistors, PNP and NPN. How the charge carriers are going to take place from PNP and NPN transistor. What are its operation, that we are going to study here. And we have different types of current components, like we can say the base current, collector current and emitter current, how they are going to be formed in the BJT. That we are going to study here based on the charge carriers, movement of the charge carriers. First, how the movement is going to take place. All these concepts what we are going to analyze in the principle of operation of the transistors. Next, we come the important point, which is the configurations of a transistor. Here we can see we have three types of configurations: common base configuration, common emitter configuration, and common collector configuration. So for what we are going to say it as a common. So the terminal is going to be common for both the input and output characteristics. That is the term why we are going to use the common here. So we are going to study the interesting part over here among these configurations for the transistors. We have its construction, its operation, and its characteristics, input and output characteristics. How we are going to get the input characteristics and output characteristics for all the three configurations, and what are its applications, that we are going to study in this part. Next, with the continuation of that, we are going to study the concept which is known as the DC and AC load line. So what is a load line, how to draw this load line, how it is going to differ for DC load line and AC load line, that all we are going to study in this part. Next comes the important point, which is the stability factor. What is a stability factor? What is the need to go for stabilization of the transistor? All these points what we are going to study here. So what the main objective is to maintain the stabilization of the transistor. How to maintain the stability as a constant for the transistor, that we are going to study concept over here. Next comes the important point, which is the thermal runaway and the stability content. That is that how a transistor can withstand from the concept of this temperature, how it is going to vary. That is the main concept of this thermal runaway. How can it withstand for various types of operating temperatures in the real-time conditions, that we are going to study. So here this comes to the last chapter. So in the last chapter, what we are going to study is completely on the transistors. What is its construction, symbol, operation, and its current components, configurations, DC and AC load line, stability factor, and its thermal runaway. So here we are going to cover the last two topics with the electronics part. That comes the complete picture of the subject principles of electrical and electronics engineering. So after studying this subject, what the student is going to learn, what is the output we are going to get from the student. So once the student is going to complete this course, he will be able to apply the circuit laws and reduce the network of DC and AC and find the response of the various parameters like voltage, current. Next, he can find the response for voltage and current for AC circuits. And he can apply the network theorems, what they have studied, like Thevenin's, Norton's or superposition theorem, to find the response. In the first chapter, we are going to find by using the mesh analysis or node analysis. In the third chapter, he is going to apply the network theorems to find the response. And here we are going to discuss again on the types of DC and AC machines, how they are going to work, its principle of operation, its construction. And he is going to have a complete idea on the rectifiers, the performance parameters of the rectifiers, half and full wave rectifiers, how they are going to be performed and what are its applications. And what is its application with and without filter, how it is going to differ. These are the outline of the concepts what they are going to learn. And they are going to learn about the special purpose of diodes, like we have seen the Zener diode, tunnel diode, varactor diode, how it is going to perform. And finally, the transistors of various configurations and the techniques in the case of BJT. Okay, I hope everyone has enjoyed the discussion on this part of overview of principles of electrical and electronics engineering. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.